Okay, so we're on to the next video. We're still going to be chatting about triangles, but this time specifically about parallel lines making triangles similar. So here I have a triangle and I've got a parallel line running through the middle with its base. Now think of all those sort of like brain teaser games when they ask you, how many triangles can you see? Well, we can see this larger triangle that takes up the whole shape. And we can see a second triangle here using that parallel line in the middle. So what I'm going to do, I'm going to just quickly draw those triangles out. So I have that smaller one that's at the top. And then I have that larger one. Shape's a little bit different, but there we go. And then I have that larger one that is the entire thing. So in both of those triangles at the very top, I have that angle which I've sort of dictated as a little star. So I'm just going to quickly draw that back in. So there we go, we've got a little, oh, that decided to completely, hang on, bear with, let me get off the shape tool. So I've got this little star at the top for both of them. So they both share that angle. Then, for my larger triangle, I've got those bottom ones. So I've got that circle down here and that green star there. But remember what parallel lines do and how they affect angles. If we recall some of our F angles, when I have an angle here, so if I have an angle above that parallel line, if I follow up this line to the next parallel line, the angle is going to be the exact same in the same spot. So above my parallel line, each angle is going to be the same all the way up. So with that in mind, if I follow this F angle here, that's got my star bit. So this bit in here is also going to be my star. So in my smaller triangle, that's a star there. And then the same idea here, I've got this other F angle. This bit here is that lighter green circle. So this bit here is also going to be a lighter green circle. And because all my corresponding angles are the same, because those two triangles are equiangular, that means these two separated triangles are similar. And that will always be the case when I've got these parallel lines. So let's take a look at some questions where we're going to be using it. So I think I've got 4 questions total. Yeah. So for these, I'm being asked to find the length of x. So the first thing I would always do is I would split up the two triangle into my 2 parts. So I've got the larger one, and then I've got the smaller one, which is just the tip. So for the smaller one, we're going to focus on that first. That's going to be that 14 and that 8. So 14, 8. And the larger one is going to have that length of x. But along the bottom there, I've got this 10 and the 14. So I need to add them up. So that's going to give me a total of 24 along the bottom there. And now I've got it similar to my questions before. I've got 2 shapes. I want to find the length of x. So that's my new shape because it has my unknown. So that's my old. So using my scale factor of new over old, the only pairs of sides where I know all the information for is at the bottom here with the 24 and the 14. So that's going to be 24 over 14, which does simplify to 12 over 7. So then x, taking that scale factor, multiplying it with its corresponding side from the old one, which is the 8. And so putting that into my calculator, comes to 13.7142 and so forth. And I'm just going to round it to 2 decimal places. 13.71. Okay, let's take a look at question 2 then. So again, I've got this larger triangle, that's the whole shape. And I've got just the top part there. So the top bit is the x and that 8. And then the larger one is that 7.5 and then the 4 plus the 8. So that's a total length of 12 there. So then doing my scale factor of new over old. That's going to be, my matching pairs are the 12 and the 8. So first I should label it. That's got my unknown, so that's my new. And then that's going to be my old. So 8 over 12. And that does just simplify to 2 over 3. So then x is going to be that 2 over 3 times by its corresponding side, which is the 7.5. And so that is just going to come out to 5, I believe, looking at it. But let's just double check. Yeah, 5. Okay. So 2 more examples. These ones are a little bit different and you'll see why in a second. So question 3. So again, I've got the larger triangle. Just going to draw them a little smaller so I do have more space for my writing. And then I've got the smaller one, which is the tip part. So that is going to be the 8 and the 12 for my smaller one. And then my larger one is going to be the 10 there, and then the x plus the 12. And I'm just going to swap it around as, I'll do x plus the 12, or 12 plus x. And I have to leave it that way because I don't know what x is. So I've got a little expression there, and you'll see how that's going to change, well, make one little added layer to this question in a moment. So I'll work through things same as before. Where my unknown is, that's got my x, so that's my new, and that's my old. So using my scale factor of new over old. Corresponding sides I've got both the bits of information for is the 10 and the 8. I still can't use the other 2 because that's still got an unknown, even if it is x plus a number. So that's going to be 10 over 8, which would just be 5 over 4. So then, that means my x plus the 12, so that whole length, x plus the 12, is going to be 5 over 4 times its corresponding side, which is the 12. Because remember, this corresponding side is matched with that one. So I do that calculation there, and I believe that's going to be 15, but I'm just going to double check. Yep, 15. So I've got x plus 12 is equal to 15. Then I've got to use my knowledge of solving equations. I want to get the x on its own, so I take away the 12 on both sides. And that gives me a final answer of x equals 15, take away 12, 3. Okay, last question here then. So same idea. Ooh, gonna just do it a bit small here. So that's my larger one. And then I've got my tip part. So the larger one, it's going to be that x plus the 9 and the 20. And then the tip part is going to be the 15 and that 9. So scale factor, new over old. That's going to be the, that's my new because it's got my x, and that makes that one my old. So that'll be the 20 over, hang on, there we go. 20 over the 15. And that would just simplify down to 4 over 3. So then the x plus 9 is going to equal 4 over 3 times its corresponding side, which is the 9. So x plus 9, 4 over 3 times 9. That's going to give me 12. So then take away the 9 on both sides, and that would give me x equals 3. X won't always equal 3. That's just how it's occurred in both of these questions. Let me know if you have any questions, and good luck with the work.